Hello, everyone. Welcome to our Deep Dive podcast, where today we'll be reviewing the technical report ScaleCUA, Scaling Open Source Computer Use Agents with Cross-Platform Data. Are you ready to explore the world of computer use agents, or CUAs, and how this paper is pushing the boundaries?
Absolutely. This is a fascinating area. CUAs are essentially agents that can autonomously operate graphical user interfaces, or GUIs, across desktops, mobiles, and web platforms. The paper's main focus is on scaling these agents using a large, diverse, and open-source dataset. Shall we start with the motivation behind this work?
Yes, let's do that. The authors point out that while vision language models, or VLMs, have made it possible for agents to interact with GUIs, there's a big challenge: the lack of large-scale, high-quality, and diverse computer use data. Unlike image-text pairs, which are abundant online, operation trajectories for GUIs are rare and expensive to collect. This bottleneck limits both the scale and generalizability of CUAs. Isn't that a significant hurdle?
It really is. The scarcity of data means that most high-performing CUAs are built on closed-source models or proprietary datasets, which aren't accessible to the broader research community. The paper's solution is to introduce ScaleCUA, which provides a large-scale, cross-platform dataset and a family of robust agent models. Can you explain how they collected such a diverse dataset?
Of course. The authors designed a cross-platform interactive data pipeline, which consists of two synergistic loops. The first is the Agent Environment Interaction Loop, where automated agents interact with various GUI environments. The second is the Agent-Human Hybrid Data Acquisition Loop, where human experts contribute high-quality, goal-directed trajectories. This dual-loop approach ensures both coverage and quality. What platforms does their dataset cover?
The dataset spans 6 major platforms: Windows, macOS, Linux, Android, iOS, and web.
That's impressive.
They also cover 3 main task domains: GUI understanding, GUI grounding, and task completion. For GUI understanding, they have 471,000 examples, for grounding, 17.1 million samples, and for task completion, over 19,000 trajectories. That's a massive scale compared to previous datasets.
Indeed, and to make the data even more useful, they designed a unified action space. This means that actions like click, write, long press, and open app are standardized across platforms, making it easier to train agents that can generalize. How did they annotate such a large dataset?
They leveraged advanced VLMs like GPT-4o and Claude 3.7 Sonnet for annotation. These models help generate appearance, position, and function descriptions for UI elements, as well as instructions and reasoning chains for trajectories. They also use data augmentation techniques, such as element cropping and synthetic resolution scaling, to increase diversity. What about the agent models themselves?
The ScaleCUA family is built on CUA Window 25-VL, a state-of-the-art vision language model. They trained 3 main models: ScaleCUA 3B, ScaleCUA 7B, and ScaleCUA 32B, with increasing parameter sizes. Each model supports 3 inference paradigms: grounding mode, direct action mode, and reasoned action mode. Can you elaborate on these modes?
Sure. In grounding mode, the agent focuses on localizing UI elements based on textual descriptions, outputting coordinates or bounding boxes. In direct action mode, the agent generates executable actions directly from observations and instructions, without intermediate reasoning. In reasoned action mode, the agent first generates a chain of thought rationale before producing the action, which improves accuracy in complex tasks. This flexibility allows the models to be used in both modular and end-to-end agent frameworks.
That's a smart design. The paper also includes extensive empirical studies. They evaluated their models on a variety of benchmarks, including MMBench GUI for understanding, ScreenSpot Pro for grounding, and WebArena Lite v2 for task completion. How did ScaleCUA perform compared to other models?
ScaleCUA achieved state-of-the-art results across the board. For example, ScaleCUA 32B scored 94.4% on MMBench GUI L1 Hard, 60.6% on OS World G, and 47.4% on WebArena Lite v2. These results surpass both open-source and proprietary baselines, demonstrating the power of scaling with cross-platform, GUI-specific data. Even the smaller models, like ScaleCUA 3B, outperformed much larger competitors in several tasks.
That's remarkable. The authors also conducted ablation studies to understand what factors contributed most to performance. They found that data augmentation, weak semantic trajectories, and high-resolution training all provided significant benefits. Interestingly, they also observed that mixing too much general-purpose multimodal data could dilute GUI-specific performance. What does this imply for future training strategies?
It suggests that a balanced approach is needed. While general multimodal data can improve reasoning abilities, too much of it can harm GUI grounding accuracy. The authors recommend data-balanced training strategies, especially as model capacity increases. They also highlight the importance of high-resolution inputs and reasoning-based inference for complex tasks, even though these come with higher computational costs.
The paper doesn't shy away from discussing limitations either. For example, the quality of agent-collected data still lags behind expert-curated data, and the current memory mechanism is quite basic. They also haven't yet incorporated advanced agentic mechanisms like reflection, memory-based decision-making, or reinforcement learning. These are promising directions for future work.
Absolutely. Another interesting point is their error analysis. They found that agents sometimes fail to understand procedural prerequisites, like selecting files before compressing them, or they get stuck in loops when actions don't produce visible state changes. On mobile, agents may ignore positional constraints in instructions, and on the web they may select visually salient but instruction-inconsistent elements. Addressing these issues will require better state tracking, memory, and semantic understanding.
The data acquisition process itself was quite challenging. For example, on Windows they had to use different APIs for different application frameworks, and on mobile they had to deal with occlusion and attribute loss in the UI hierarchy. On the web, they had to simulate browser UI components that aren't captured by automation tools. Their solutions, like adaptive bounding box tightening and deep exploration algorithms, are quite innovative.
Yes, and their open-source approach is a major contribution. By releasing the data, models, and code, they're enabling the broader research community to build on their work. This is crucial for advancing the field, as it breaks the reliance on proprietary datasets and closed-source models.
Let's talk a bit more about the evaluation benchmarks. The authors use both offline and online benchmarks, covering desktop, mobile, and web environments. For web, they refined the WebArena Lite benchmark to ensure tasks could be solved in both headed and headless environments, and that all tasks provided sufficient visual information for pure vision-based evaluation. This attention to evaluation methodology is commendable.
I agree. They also used a variety of public datasets for training, such as CClick, GUIenv, and Android Control, but their own ScaleCUA data is the most comprehensive, covering all three task domains across all major platforms. Their annotation prompts and data processing pipelines are also released for reproducibility.
The paper's impact goes beyond just technical contributions. By standardizing the action space and providing a unified foundation for training and evaluating GUI agents, they're setting the stage for future research in this area. They hope that ScaleCUA will serve as a solid foundation for building capable, trustworthy, and deployable computer use agents.
That's a great point. The field of computer use agents is rapidly evolving, and the need for open, scalable, and generalizable solutions is greater than ever. ScaleCUA addresses many of the current bottlenecks and provides a roadmap for future advancements.
Before we wrap up, let's summarize the key takeaways from this paper. First, the lack of large-scale, high-quality GUI interaction data has been a major bottleneck for CUAs. ScaleCUA addresses this by providing a massive, cross-platform dataset and a family of robust agent models.
Second, their dual-loop data pipeline, combining automated and expert-driven data collection, ensures both coverage and quality. Their unified action space and flexible inference paradigms make it possible to train agents that can generalize across platforms and tasks.
Third, their empirical results show that scaling with GUI-specific data leads to state-of-the-art performance in understanding, grounding, and task completion. Data augmentation, high-resolution training, and reasoning-based inference all contribute to these gains.
Fourth, they openly discuss the limitations and challenges, such as the need for better memory mechanisms and advanced agentic workflows. Their open-source approach paves the way for the community to address these challenges together.
And finally, by releasing their data, models, and code, they're democratizing access to high-quality resources for building and evaluating computer use agents. This is a significant step forward for the field.
Well said. This paper is a milestone in the development of open, scalable, and general-purpose computer use agents. It will be exciting to see how the community builds on this foundation in the coming years.
That brings us to the end of our review. Thank you for joining us on this deep dive into ScaleCUA. We hope you found it informative and inspiring. Any final thoughts?
Just that ScaleCUA sets a new standard for open research in computer use agents. If you're interested in this field, be sure to check out their GitHub repository and explore the data and models yourself.
Absolutely. Thanks for listening, and stay tuned for our next episode, where we'll continue to explore the latest breakthroughs in AI research. Until next time.
Goodbye, everyone.
To summarize, ScaleCUA introduces a large-scale, cross-platform dataset and a family of robust agent models, achieving state-of-the-art results in GUI understanding, grounding, and task completion, and sets a new benchmark for open, scalable computer use agents.